You'd think by now we'd have space figured out. We've sent probes to the edge of the solar system, landed robots on Mars, photographed galaxies billions of light years away. We've built mathematical models that predict cosmic behavior with stunning accuracy. We can tell you what happened nanoseconds after the Big Bang. And yet space keeps throwing curveballs. Not little inconsistencies or minor anomalies. Full-blown discoveries that make scientists scratch their heads and say, that shouldn't be possible. These aren't mysteries from 100 years ago. These are recent observations made with cutting-edge technology that directly contradict what we think we know about how the universe works. Here are 10 of them. Starting at number 10, we have the hexagon on Saturn. Saturn has storms. That's normal. Gas giants have weather patterns. Jupiter has the Great Red Spot. Neptune has dark spots that come and go. Storms on gas giants are expected and thoroughly understood. Then there's Saturn's North Pole. At Saturn's North Pole sits a massive hexagonal storm system. Not circular, not oval. Hexagonal. 6 perfectly straight sides forming a geometric shape roughly 20,000 miles across. Each side of the hexagon is longer than Earth's diameter. The Voyager spacecraft first spotted it in 1981. When Cassini arrived at Saturn in 2006, it was still there. Same shape, same position. Still a perfect hexagon. Scientists have proposed explanations involving jet stream patterns and rotating fluid dynamics, and these models can produce hexagonal patterns under very specific laboratory conditions. But here's the problem. No other planet has anything like this. Not Jupiter, not Uranus, not Neptune, just Saturn. And nobody can fully explain why Saturn's atmospheric dynamics would produce this specific geometric pattern when no other gas giant does. It sits there, perfectly hexagonal, defying every expectation of how storms should behave. At number 9, we have the missing antimatter. When the universe began, the Big Bang should have created exactly equal amounts of matter and antimatter. That's what every physical law predicts. Matter and antimatter are perfect mirrors of each other. Except the universe played favorites. If matter and antimatter had been created in equal amounts, they would have annihilated each other completely. The entire universe should be nothing but leftover energy. No atoms, no stars, no planets. Nothing. But we exist. Galaxies exist. The universe is overwhelmingly made of matter with almost no antimatter anywhere. Something tipped the scales. For every billion matter-antimatter pairs that annihilated, there was one extra matter particle left over. That tiny surplus became everything. Scientists call this asymmetry CP violation, and while we have some theoretical frameworks, none of them explain an imbalance large enough to produce the universe we observe. Our best models are off by a factor of about 1 billion. We exist because the universe broke its own rules at the very beginning, and we have no idea why. Number 8 is the perplexing phosphine on Venus. Venus is hell. Surface temperatures hot enough to melt lead. Atmospheric pressure 90 times greater than Earth. Clouds made of sulfuric acid. Nothing should be alive there. Then, in 2020, scientists detected phosphine in Venus's atmosphere. Phosphine is a gas that on Earth is produced almost exclusively by biological processes or industrial activity. It breaks down quickly in the presence of oxygen and ultraviolet light, so if it's being detected in Venus's atmosphere, something must be continuously producing it. Scientists scrambled to find non-biological explanations, volcanic activity, lightning, chemical reactions in the clouds. But every proposed mechanism produces phosphine at levels thousands of times lower than what was detected. The discovery has been challenged and debated intensely. Some follow-up observations haven't confirmed it. Others have. But if the phosphine is really there at the levels initially reported, we have a serious problem. Because the only processes we know that produce that much phosphine involve life. Nobody is saying there's definitely life on Venus, but nobody can definitively explain the phosphine either. At number 7, we have Oumuamua's impossible acceleration. In October 2017, astronomers detected the first confirmed interstellar object passing through our solar system. They named it Oumuamua, Hawaiian for scout. It was cigar-shaped, tumbling end over end, moving fast. As telescopes tracked it, they noticed something strange. Oumuamua was accelerating. Not a lot, but measurably. It was speeding up as it moved away from the sun. Comets do this through outgassing, ice vaporizing and creating jets of gas that push them. Except Oumuamua showed no signs of outgassing, no tail, no coma, no detectable jets. It was accelerating without any visible mechanism causing the acceleration. Scientists proposed it might be covered in hydrogen ice, or made of nitrogen ice, or extremely porous and outgassing subtly. Each explanation has problems. Hydrogen ice sublimates at temperatures Oumuamua never reached. Nitrogen ice can't form in the environments where interstellar objects originate. One scientist proposed it might be artificial, a light sail from another civilization. This was widely criticized, but notably, nobody has provided a natural explanation that fits all the observations either. Oumuamua remains the only object we've ever observed that accelerated without a visible cause. Number 6 is the repeated fast radio bursts from FRB 121102. Fast radio bursts are mysterious enough on their own. Incredibly powerful bursts of radio waves lasting milliseconds, releasing more energy than the sun produces in days. Then came FRB 121102. This source repeats, constantly. It has produced thousands of bursts since its discovery. And in 2020, scientists found something even stranger. It repeats on a schedule, active for about 90 days, then silent for 67 days, a precise 157-day cycle. Natural astrophysical processes don't usually follow schedules. Stars don't care about calendars. The regularity suggests something mechanical, something structured. Scientists have proposed models involving binary star systems and exotic orbital mechanics, but every model requires very specific, very unlikely configurations, and none of them explain why this particular source behaves so differently from all the others. The universe is beaming structured, repeating signals at us from 3 billion light-years away, and we don't know what's making them or why they follow a pattern. At number 5, we have Saturn's moons creating rings that shouldn't exist. Saturn's rings are iconic and mostly understood. We know how ring systems form and how they're maintained. The physics is solid. Then scientists discovered some of Saturn's tiny inner moons are creating ring structures that violate the known physics of how rings should behave. These moons create ripples and structures that propagate in ways standard models can't predict. Janus and Epimetheus swap orbits every 4 years, creating chaotic gravitational effects. Prometheus creates kinks and braids in the F-ring that appear and disappear unpredictably. The more precisely scientists measure these interactions, the less sense they make. The moons are too small to create the effects being observed. The gravitational perturbations don't add up. Something about the way these tiny moons interact with ring particles is happening through mechanisms we haven't accounted for. Saturn's rings are textbook astronomy, and yet they're doing things the textbooks say they shouldn't. Number 4 is the galaxy with no dark matter. For decades, the evidence for dark matter has been overwhelming. Galaxies rotate too fast to be held together by visible matter alone. Dark matter is foundational to modern cosmology. Then astronomers found NGC 1052-DF2, a galaxy with almost no dark matter. And it's stable. It's rotating at exactly the speed you'd expect if it contained only visible matter. No anomalous rotation, no missing mass. This shouldn't be possible. If dark matter is necessary to hold galaxies together, every galaxy should have it. Finding one without it is like finding a car driving with no engine. Scientists proposed it might have been stripped of its dark matter by another galaxy, but the structure doesn't show signs of violent interaction. Then they found more of them. An entire class of galaxies apparently lacking the dark matter that cosmological models say should be there. Either something is stripping dark matter in ways we don't understand, or our entire framework needs rethinking. At number 3, we have the mysterious gamma-ray burst that broke records. Gamma-ray bursts are the most powerful explosions in the universe. They happen when massive stars collapse into black holes or when neutron stars collide. On October 9, 2022, telescopes detected GRB2 21009A. This gamma-ray burst was the brightest ever recorded, by a lot. It saturated detectors across the electromagnetic spectrum. It ionized Earth's upper atmosphere from 2.4 billion light-years away. Scientists nicknamed it BOAT, brightest of all time. But the amount of energy released doesn't match any model of gamma-ray burst production. The burst was too bright, too energetic, too long-lasting. Even accounting for it being relatively close, the energy output exceeded what current models can produce. Something created an explosion more powerful than anything we've seen before, using a mechanism we don't understand. And we'll probably never figure out exactly what caused it, because the object is now either a black hole or a rapidly cooling neutron star billions of light years away. At number 2, we have the alignment of quasar rotation axes across billions of light years. Quasars are supermassive black holes actively feeding on matter and shooting jets into space. Each quasar is an independent object separated by hundreds of millions or billions of light years. They have no physical connection to each other. So why are their rotation axes aligned? In 2014, astronomers studying 93 quasars found that their rotation axes weren't random. They were parallel. These quasars are separated by billions of light years. There's no force, no field, no physical mechanism that could coordinate their rotations across such enormous distances. The probability of this alignment happening randomly is astronomically small. Yet there it is. Quasars across a region of space 4 billion light-years wide, all spinning in nearly the same direction. Scientists have proposed that large-scale structures in the early universe somehow imprinted preferred directions, but this explanation is vague and doesn't account for how such an alignment could persist for billions of years. And finally, at number 1, we have the cold spot in the cosmic microwave background. The cosmic microwave background is the afterglow of the Big Bang, the oldest light in the universe. It's incredibly uniform, showing tiny temperature variations that match our cosmological models beautifully, except for one spot. The cold spot is a region about 1.8 billion light-years across, where the temperature is significantly lower than it should be. The probability of this occurring naturally is less than 2%. It's not supposed to be there. Scientists initially proposed it was caused by a supervoid, an unusually empty region of space. But surveys found the void isn't large enough or empty enough to explain the temperature anomaly. The most radical explanation? It's a bruise. A place where our universe collided with another universe during the earliest moments of the Big Bang. In some multiverse theories, universes can interact during their formation, leaving marks in the cosmic microwave background. This explanation is highly speculative and untestable with current technology, but it's also the only explanation that actually fits the data. The cold spot might be direct physical evidence that other universes exist and that ours bumped into one of them 13.8 billion years ago. If true, it's not just unexplained, it's proof that reality is far larger and stranger than we ever imagined. 10 discoveries, all of them observed, measured, and confirmed by multiple independent teams, and none of them fully explained by our current understanding of physics. Every telescope we build, every probe we send has the potential to find something that rewrites the rules entirely. That's what makes space so compelling. We're not exploring a museum of things we already understand. We're exploring an active mystery that keeps surprising us. If you want more mind-bending cosmic mysteries, hit that subscribe button and turn on notifications so you never miss an upload.